researchers have discovered a mechanistic connection between levels of zinc in human bodies and the risk of type 2 diabetes and fatty liver disease. The researchers provide solid evidence through their state-of-the-art genetic analysis of a large population of human participants and comprehensive lab studies of a potential therapeutic target for non-alcoholic fatty liver disease and type 2 diabetes. We know that increasing zinc intake improves blood glucose control in people with prediabetes or type 2 diabetes, and people with a mutation in a key zinc transporter protein have reduced risk of diabetes, says first author Shek-Man Chim, principal scientist at Regeneron Pharmaceuticals, Inc., New York, U.S. However, the mechanism for how zinc influences systemic blood glucose levels and diabetes risk remains unclear. To explore the diabetes protective role of zinc, Chim and colleagues tested loss-of-function mutations from genetic sequence data collected from a large population of participants of European ancestry who took part in the Regeneron Genetics Center Geisinger Health System DISCO-VIR study. This identified a rare mutation that causes loss of function in a zinc transporter protein called SLC39A5, associated with increased circulating zinc levels. This confirmed that circulating zinc levels in carriers of the SLC39A5 loss-of-function mutation were elevated and associated with a reduced risk of diabetes. Having identified SLC39A5 as an important clinical link between zinc and diabetes, the team explored its function by genetically engineering mice lacking the zinc transporter protein. Given that diabetes often coincides with non-alcoholic fatty liver disease, the team explored whether loss of SLC39A5 protects the liver, too. As hoped, mice lacking SLC39A5 had less buildup of fat in the liver and in blood markers of liver damage. Moreover, mice lacking SLC39A5 but fed a high-fat, high-fructose diet also had less fat accumulation in the liver and improved insulin sensitivity compared to control mice. The improvements seen in the livers of mice lacking SLC39A5 prompted the researchers to see whether loss of SLC39A5 protects against progression of non-alcoholic fatty liver disease to non-alcoholic steatohepatitis, a more severe liver inflammation that leads to potentially irreversible scarring. By contrast, the mice lacking SLC39A5 had reduced liver damage markers, fasting blood glucose, and improvements in liver inflammation and fibrosis.